Good morning, Fancy Meat Computers! How is everybody doing today? I hope that you're doing okay. I hope that everything is doing pretty well in student land. Yes. So the dab emoji is actually, I think, supposed to be cough into elbow emoji, but because they've got the other, yeah. Yeah. So I actually want to announce an exciting new initiative with respect to this class and the morning music that leads the class off. I am going to take by email suggestions for music tracks, but there are rules. First rule, no lyrics. Second rule, has to be from a royalty-free music site, because I have to be able to put it on the stream. So I would prefer no attribution as well, just because it's a pain in the butt. But yeah, so if you have some free time over the weekend and you'd like to see if you can get some music into the stream, then I'm taking suggestions. Yeah, I'll add it to the rotation. Any good tracks with an X. Yeah, it's kind of funny. The first time somebody asked me to drop the tracks, I thought they meant like stop playing the tracks, because I'm old, and according to old man speak, which is what I speak, drop means to get rid of, but apparently when you're on a stream, drop means drop the information, as in tell me the information, which was that was a delightful misunderstanding over the summer semester. Yeah. Zelda and chill. Maybe. Well, again, has to be royalty free. Has to be royalty free. What if somebody makes a custom track? Well, that would mean that if you made a track and then gave it to me and gave me permission to play it, then there you go. Someone asked me what music I'm into. Lately, I've been it's been mostly like worky times music. So it's been like lo-fi hop, jazz hop, lo-fi. There's this really good YouTube video called Swing Hop, where it's like lo-fi jazz music from like the 30s, which is really, really cool. I really like it. Drop table music. No! I get SQL references. Yeah. So, yeah. Anyway. Yes. I also listen to a certain amount of, like, synthwave. Synthwave is cool. I tried vaporwave, but I couldn't really get into it. It's just a little bit, like, I don't know what it is. It just grates on my nerves a little bit. Perhaps because it is, like, slightly intended to. But, no, I like chillwave. I like synthwave. I like all that kind of jazzy stuff. Actually, lately my YouTube feed has been giving me suggestions for like actual jazz albums that were released in the 70s, which are very funky, and I like them a lot. But anyway, gosh, can't have. Okay, I need to shut off Slack because my TAs are posting things with skull emojis in them. Okay. What's Slack? Leave. Thank you. Okay, so let's get back into it. Let me just check to see if we have no announcements pending. Doop doop doop. Nope, everything's fine. I think I might have messed up Sarth's office hours. I think I put him down for Monday, but he's actually Wednesday. But we'll have that sorted out by the end of the day today. But yeah, okay, so we were going to talk about expressions. Express yourself. Express yourself. All right. So, we had talked about literal scalars. Literals are, of course, let me start up my my drop-down terminal thing. There we go. Python 3. Haha. So scalars are things which are indivisible. You can also think of them as being atomic. So you can't break them down into smaller pieces. That's what makes them atomic. So it's not really much. It doesn't really say much to say that numbers like 3 and 2.5 are objects. Python is an object-oriented language, so pretty much anything that's in Python is going to be an object. Oh, actually, if you want a recommendation, I also really like chiptune, and there's this really good chiptune artist that's been popping up in my feed lately called Fear of Dark. He's got he or she, or yeah, this person has some pretty good stuff. So anyway, yes. So literals. The thing that distinguishes a literal is that they actually represent what you type, right? Most of the time when we're programming, we're working in symbols that represent other things. But when we are typing out a literal, we want, literally that number to enter the program. The microphone keeps cutting in and out. Ooh, let's see. Have I got microphone problems? Let's see. I think that might be on. I think that might be on your end. I think that might be on your end, Carl. There we go. So, literals are fine. Literals are good. Everybody likes literals. So, now let's talk a little bit about data types. Those of you who've never programmed before, this shouldn't be too bad. But this is like, we are dipping our toes into such a huge area of computer science, like type theory and type systems. I'm teaching 3MI3 at the moment. Notice how the textbook is called Types and Programming Languages. Well, I'll tell you, this textbook in particular is like 50% types and 50% programming languages. So typing is actually a reasonably, it's an advanced level skill. It's no trouble. However, at your level, at this level, at the intro level, it's actually pretty easy. The idea is, when you have a variable or an argument to a function or a literal, each one of those things will have associated with it a data type. So the first and most basic data type is the integer. So integer, if you remember back to your high school math class, if you remember the difference between the integers and the real numbers, that is the difference, roughly speaking, between integers and floats. Question: do you need to declare data types in Python? No! Python uses a system for typing called duck typing, which basically means if it looks like a duck and it walks like a duck and it quacks like a duck, then it's a duck. So that is a complicated way of saying that a thing has the type. Basically, the way that you use it determines its type, which is stupid and one of the things I hate about Python. But, it makes it easier for beginners, I guess. So, but you should know what integers and floating points are, for sure. So, integers are just positive or negative whole numbers, right? Whereas a floating point number, that represents all the real numbers, and it does not have perfect precision. We're going to get into floating point in a fair amount of depth around topic 5 territory, so we're not going to do a super big amount of it at the moment, but I'll show you something interesting about floating point numbers just to demonstrate to you that they're not completely precise. I'll do this here so that I can blow it up. Boom. 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 There we go. All right. So, floating point number. 0.1 is a floating point number. 0.1 plus 0.1 plus 0.1. That's 4, 5, 6, 7, 8, 9, 10. So I have 0.1 added to itself 10 times. What would the result be? Ask yourself this question. I will wait for you to respond in the chat. We'll come back to this after the next slide. So, operators can be applied to objects to form expressions that yield other objects. Oh, I've got some questions, actually. Do you have any other assignments apart from A1 that you have to submit? Not for this class! For this class, you will only have to do one assignment at a time. Yes. Someone knows the answer. So most people are saying 1.0. Not true. In actual fact, if you add 0.1 together all this number of times, you'll get 0.9999999. And the reason for that, very roughly speaking, is because these guys they do not have perfect precision. That imperfect precision, generally speaking, won't show up unless you've performed enough mathematical operations that accumulate the imprecision to such a degree that it then becomes manifest. It shows up because you've basically multiplied the amount of imprecision by a factor of 10 by performing this subsequent addition. So, in order to show you exactly why this happens at the binary level, we're going to have to get into it. Again, we're going to talk about this again in topic 5, I believe. So, we'll put a pin in this, and we'll come back to this issue in a little bit. Just keep, the thing I'm trying to impress upon you is that floating point numbers are not to be relied upon for exact comparison. So, if you were trying to compare that to 1.0, that would come out false, even though, according to your own mental arithmetic, this should certainly be true. So, there we go. Anyway, so, operators, yes. So you can make expressions out of operators. The operators that we have available are right here. Let me see, is there anything important on the slide? Oh, yes. You can tell what type something is by using the type function. So type of 0.1 is class float. Type of 1 is int. Type of true is Boolean. Type of type is type of I or 1. There we go. There you go. Class. So the type of type is type. There you go. So here are some questions. I'll do these quickly for you. So what about 0.5 plus 0.5? Nope, that works. What about 0.1 times 1.0? Or times 10, sorry. Nope, that works. What about 0.1 plus 0.2? Haha, there you go. That one's imprecise. So, yeah, it's with floating point numbers, you will get very, very small imprecisions depending on what operation you perform. But it does depend on what operation you perform. But yeah. So, here is your selection of basic arithmetic operators. So we distinguish so you'll hear me talk about three types of operators primarily. Arithmetic operators, which are operating on numbers, Boolean operators, which operate on Booleans, and comparators, which are basically comparison tests. Yeah, I already did that. So, you have addition, subtraction, multiplication. Those are they're about the same as you would expect. However, we have two different types of division, and one which you might not have seen before, or one that you haven't seen since elementary school. So, we have both integer division and floating point division. So if I say, for example, 7 divided by 8, the answer is 0.875. If, on the other hand, I integer divide 7 by 8, I get 0. What if I do 38 divided by 8? I get 4.75. If I integer divide that, I get 4. So, essentially, what integer division does is it performs the division but ignores any decimal value. Like it rounds down to the nearest whole number. So you can think of it like long division, right? When you do long division, you get two parts in your answer, right? You'll get the number, and then you'll get a remainder. Integer division is the number, and modulus is the remainder. There you go. So the percent sign is the modulus operator. It is the remainder of integer division. The modulus operator is extremely useful. It can turn a series of increasing numbers into a looping series of numbers. So I recommend getting used to the modulus operator. Yes. So did I get 0.9999999 because arithmetic of floating numbers are at just best approximations? It's not so much. It's not because it's the best approximation. It's because the underlying binary representation cannot represent a number like 0.1, which has finite representation inside of the decimal system. Like inside of the decimal system, 0.1 has finite precision, right? You can say 0.1. However, inside of inside of a binary system, that number, 0.1, has actually an infinite tail in the same way that you can't write 1/3 inside of the decimal system without an infinite tail of decimals. So it's again, we're going to get back to it, but that's the answer. It's because a pure binary number cannot represent it with finite precision. So you have to chop it off at some point. And that causes imprecision. So, yes. So integer division is just like floor. Well, it's like division plus floor. Yeah, it's floating point division plus floor. Yes. Floor so floor rounds down, ceiling rounds up. But yeah. Are there any types for decimals with more precision? So, in general, Python likes for you to not have to worry about it. So, I don't know. To be honest, I've never tried using a double in Python, but yeah, I don't know. There are libraries for it. We're gonna explore those libraries later on. But yeah, there are ways to get around it for sure. So is division plus floor equally efficient to just using integer division? No, I wouldn't think so. But yeah, possibly. I don't think so, because it requires a function call. And, of course, exponentiation is 2 asterisks. So, I got ahead of the slides again. So, some quick notes. Your rules of order, your order of operation is, generally speaking, BEDMAS rules apply. However, the safest thing to do is to add your own parentheses to ensure you get the type of answer that you want. You can also shift things from one representation to another. You can shift things from integer to float and then from float to integer by applying operators that produce one or the other result. So floating point division obviously produces a floating point number, and integer division produces an integer number. So here's a question. If we have a floating point number to begin with, and we have an integer number, and we have integer division, it still produces a float. There you go. Float is kind of like, it's a sticky type. It'll stick to most things, and it's kind of hard to get rid of. The way that you get rid of it is by using round. That turns it back into an integer. Notice that the 0.0 has disappeared. You can tell it's a float because it has 0.0 on it, even if it's a whole number. What if you integer divide a negative number? -5 divide by 6. Or integer divide. -1. So it's still flooring, right? So it's still going to the... So it's still going down. It's still rounding down, but it's rounding down to the height, like it's rounding down to integers of greater magnitude when you're in the negative half of the plane. Is it like the smaller we go, the more imprecision it shows? Yes, yep. Yeah, the imprecision is a fixed amount, so the smaller the number is, well, it's kind of like that. We'll get into it. I will hold the rest of the floating point questions for when we're talking about them in detail in a few weeks, about a month from now. You can't you also use the int function? Absolutely. So you can explicitly convert between things by using either the int or float functions, which perform type conversion. These are very useful, actually, and we're going to... I find the ones that convert data structures to be the most useful, but yes. If you use int, does it round up or down? Good question. So int of 5.7, 5. Int of 5.2, 5. So it's rounding down. It is performing floor. So we can get unexpected answers due to imprecision of floating point representation. I already gave you that demo. You could also round out the floating point error. This is true. Yep. Many math functions are available, but they are not in the core language, quote unquote. Instead, we must import the math library. So, as with many programming languages, a lot of the functions that you may wish to use do not come with the... they do not come by default into your program. You have to specifically request that the functions are included. Now, Python includes a lot more stuff by default than another language like C would. But there are certain things that you have to explicitly import. So the way that you get a library into your code is you type import, and then you type the name of the library. In this case, import math. So now that I have math imported, I've got a whole heck of a lot of special math functions that I didn't have before. Like, for example, logarithms, trigonometric functions, stuff like that. So, math log base 2 of 256 is 8.0. So that's the base 2 logarithm. If you want the base 10 logarithm, you just exclude the 2. If you want... Get out of here with pandas. Math.cos 2 times math.pi, path, math.pi. There you go. Math.pi is equal to 3.14, etc., etc. So, if only you could import math into your brain like that. Yes, indeed. Very true. But yeah, so if you're looking for a mathematical function and you import math, no. If you're looking for a mathematical function and you don't have it by default, chances are it's inside of the math library. Cool. So let's talk now about variables. Now that we know how to write expressions, we need to learn how to write variables, right? So variables are a different concept in programming than they are in your regular algebraic sense. So, if you remember back from your, late elementary school, early high school algebra classes, a variable is a thing that can stand for any number of numbers. And normally the object of a math problem would be to solve for x. Find the exact value that x must have because of the arrangement of the equation. In the case of a computer variable, it is related because a variable can have many different values, but the big distinction is a variable in the computer sense always has a specific concrete value. And the reason for this is that variables are simply named segments of memory. So when you store data in a computer program, that data gets stored into a variable or into a larger data structure, but larger data structures are just generalizations of the variables that we're now talking about. So, for example, if I have the variable x and I assign it the value of 5, if I call x, if I ask what x is, I will always get 5 back until I overwrite that with something else. So if I set x equal to 8, x is 8. There is no trace kept of x's previous values. When you write something to a variable, that variable gets overwritten. It works the same way as files, like files in your file system. If you have a file in your file system and you rename something else to the name of that file, and it says, do you want to replace this file with the other one? And you say yes, that file is gonzo. Well, in a properly supported operating system, they probably just kick it out to the recycle bin. But inside of Python, there is no recycle bin. Once you have overwritten a variable, kiss it goodbye. So that's an important thing to know about variables. It's much better to think of a variable as like a stick-it note, right? And you write something on your stick-it note, and then you put it on your other screen, and then when you need to write something else on that stick-it note, you scratch it out and put a new stick-it note on it. Is there a way to keep track of what variables you have declared? I don't know, actually. I don't know. Possibly. Probably. I don't know. Some Python whiz kid in the chat probably has an answer. Can you assign variables like x1 and x2? So no, you can't do assignment to multiple variables on one line. So you can't like do x1 x2 is equal to 4 because that's an error. You can do x1 x2 is equal to 4 5. That way x1 is 4 and x2 is 5, but you can't do like one to many. Oh, can you do that? Sorry, let me see this. Again. Well, let me see here. Well, there you go. Interesting. I didn't know that. Python has all these little tricks. Yeah. So, yeah, the question was kind of, can you do that from within Python itself? And my answer is, I'm not sure. But, yeah, you can definitely get, like, IDEs that'll show you all of your variables at once. But, yeah. Yeah, and we're going to get to breakpoints. We're going to get to that stuff. Actually, this would be a good time to show you Python Tutor, wouldn't it? So, this is an extremely valuable website. I recommend highly using Python Tutor. So what Python Tutor is it's a little interface where you can enter in a Python program. Like, for example, the one that we're working on now. Base is 5, height is 4, area equals base times height divide by 2. If you click Visualize Execution, let me just blow that up. You can actually step through your program one line at a time, and it will show you what your variables' values are. Oh, height not defined. I got a syntax error. Doop doop doop. Edit the code. Oh, there we go. I hate it when, like, Control-D is delete. That's my least favorite shortcut. Get out of here, you. So there you go. With Python Tutor, if you do stuff inside of the Python Tutor environment, you can see all of the variables you have declared and what their values are at any point in the execution of your program. This is extremely valuable. What it saves you the work. It saves you the work of having to do it explicitly in print statements like I was doing previously during the Topic 1 example programs. So Python Tutor, extremely valuable. Write this URL down, and I would even recommend, like, for the first few assignments, if you're a person who's learning programming for the first time, I would even recommend doing your assignment problems for, like, the first couple of assignments in it, and then, like, copying it into your assignment notebook, because that, like, really helps. Yeah. Yeah, these little tidbits of tips and tricks outside the lecture is where the real gold is. Yes! Especially, like, I try to make the lecture entertaining for everyone, not just the people who don't know, like, you know. Debug mode is the same for most IDEs. This is true. It is kind of a debugger, but the difference between Python Tutor and, like, a regular debugger is that you have a timeline here that you can go through. Like, you can also set breakpoints here, but all that breakpoints do here is that just, like, indicates the points in the timeline that this break occurs at. So I actually think that this is better than, like, the traditional breakpoint system. But yeah, this, and And if you take a look at their homepage, it doesn't just do Python. It also does Java, C, C++, JavaScript, and Ruby. But again, this is a Python course, so Python is the language we'll be using for it. But yeah, this is like, there's some appreciation coming in for the people who know programming. But yeah, so yes, so variables, the absolute correct way to think about a variable is as a piece of memory that you are manipulating, because that's what it actually is. In what format do you have to submit the A1 assignment? Please submit it in the form of a Jupyter notebook, because we might let you get away with not submitting it as a Jupyter notebook for the first one, but definitely not for the second one. Our expectation is that your assignments will come in the form of Jupyter notebooks. Like, with A1, you can enter the answers like right in the notebook, and if you're logged into Jupyter, all you have to do is like submit from this fetch screen, and then your assignment is submitted. If you're working locally and you've downloaded it from Avenue, please upload it back to Avenue when you're finished with it. But yeah. Oh, ln might just be math.ln. Nope. Log n. I think you can also, like, if you do like log 10 and then math.e. Yeah. So if you have the second argument here, you can do the logarithm of like any number. So you can just put e in there. So the Jupyter notebooks have the .ipynb file extension. Yeah, so hopefully that's good information. Log normally has base E in Python if not defined. Oh, that's interesting. So math log of math.e. Yeah, okay. Confirmed. Yeah, sorry, I thought it was base 10 for some reason. Yeah. So if you want the base 10 logarithm, you'd have to specify it explicitly. Yeah. This is cool. Yeah, that's the thing about programming, is like, once you understand that functions take arguments, you can have pretty general procedures. So anyway, that's variables. Variables can contain uppercase and lowercase letters, digits, and the underscore character. Variables must not start with a digit and must not be one of the reserved words or keywords of Python. If you want to see a full list of the reserved words in Python, which may be of interest to the veteran programmers out there, import keyword keyword.kw list. And these are all the things that are not allowed to be variable names. And there's good reason for that, right? Like, you know that we use if. We use if to mean if statement. What if you had a variable that was called if? That doesn't make any sense. If should be just for the language. So just use it for the language. But yeah, relative to a lot of languages, that's actually a pretty small set of keywords. I just want to point that out. So, assignment for variables. We've already done this a few times. Assignment, written equal sign, changes the state. A is equal to 4, for example. It is an instruction, command, or statement to change a value, not a check on whether the two values are the same. We pronounce A equals 4 as A becomes 4. Later on, we'll see double equals, which means please check to see if these are the same value. So, like x is equal to 5, y is equal to 6, x becomes 5, y becomes 6. x is equal to y? Question mark? False. What if y is changed? What if y becomes 5? Then x equal y? True. There you go. So I already did an... Oh, no. There we go. I already did an exam... There we go. I already did an example of multiple assignment. There's a traditional example. I'm glad that you find this stuff cool, because this is programming, man. So there's a traditional example to demonstrate how variables work. Python 3. So if I have a value in x, say I have 3 in x, and y is 9. Let's say I wanted to swap the values in these two variables, right? The naive way of doing it would be to say x is equal to y and y is equal to x, right? We've just swapped the values. So let's see what they are. X is now equal to 9, and y... Oop. Oh no. Whoops. I exited it. Y 9, x equals y, y equals x, x is 9, y is also 9. So you can see the 3 that was supposed to end up in y was actually obliterated. Are the assignments graded only off of the private test cases? Yes. So without getting into it too detailed, because I'm in the middle of a class, with the assignments, everything is graded automatically using the autograder. However, if you feel that the autograder has been unfair to you in some way, you always, in this class, have the right to contest something that the autograder has graded you. Like, you always have the right to contest an autograder grade, bring it up with a TA, and the TA will, either explain to you how you're wrong or give you maybe some marks if it's correct that the autograder didn't mark you correctly. So, however, mark you correctly is kind of, sometimes students and teaching staff have a difference of opinion over what constitutes being marked correctly. But, yes. Yes. So why is y 9 and not 3? Well, if we break it down, let's pull this into Python Tutor, which I think I closed it because it was messing me up. Python Tutor. There we go. So if we do x is equal to 3, y is equal to 9, x is equal to y, y is equal to x, visualize the execution. X is 3, that's good. Y is 9, that's good. Now, notice, in the next step, x goes from 3 to 9. So, when we execute the final step and set y equal to x, what we're setting back there is in fact 9, which doesn't change y. So this swap operation didn't work. What you actually have to do is you have to introduce a third variable. And yes, I know in Python there's a specific syntax. In Python, and that's actually on the slide, you can swap two values by doing this. But I'm going to show you how Python does that under the hood with actual memory. So what's actually going on is, rather than setting x to y immediately, we're setting a temporary variable to the value of x, right? So we have a temporary variable. We are storing in it the value of x. we can then assign to x the value of y, and we can assign to y the value in the temporary variable. So x is 3, y is 9, temp is 3, x becomes 3, y gets the value in temp, which was 3, which was x's old value. So that's how you actually swap to values, and that's how it works in pretty much every language that doesn't have specific syntax for it, unlike Python. I use Brave because it doesn't show YouTube ads. Well, I mean, that is definitely a convenient corollary of me using it. It's pretty incredible, actually. Like, I've only had this computer since mid-August, and look how much. Look at my stats. This is how much time and bandwidth and the number of ads that have been blocked. That's kind of incredible, isn't it? Yeah. Yeah, so that's swapping. Gonna skip the quiz because I did an example. So, when you name variables, try to name them something that means something, right? Up to this point, I've just been doing simple numerical examples. So using x and y, it's, useful because it pulls it back to like your algebraic kind of algebraic variables. However, when you're programming in an actual program, you'll often want those variables to say something about the data they contain. So rather than just saying a, b, and c, here we can say pi, radius, and area. That makes it very clear what it is that we're actually calculating. We're calculating the area of a circle. What computer do I have? It's the Asus TUF Gaming A15. It's PC Gamer's mid-range gaming laptop of the year for the current year. Did I name my computer the Beast? Yes. Yeah, I did. Nick at the Beast. So, yeah, that's just a little, that's just a little, yeah. Yeah, I did. Nick is my username because that is my name. The Beast is the name of my computer. So I am user@computer. That's how the bash prompt works. Is coding in Python completely different from programming in a language like C, or are there similarities? There are a lot of similarities between C and Python. Python is a C-based language, so a lot of this kind of lower level stuff that we're talking about during this lecture, this is stuff that is definitely transferable to C. There will be syntactic differences, but generally speaking, most of the stuff we're talking about will be applicable until we start talking about data structures. Yeah, at any point in this course, if you ever are curious if something actually applies to C as well, just ask me and I'll tell you, because I know. Haha. Do I play any games? I've been playing Fez recently. I believe C will have a more expressive syntax, as in, if you want to print something, you won't have something as easy as print in C. Well, I guess you'll just have to take 1x, C3, and C, won't you? So to speak. So, that's just the directory I'm in. So, in Linux, if you type pwd, that's print working directory. So this is like the directory that I have my PDFs for this course's slides in. That's what that means. That's just like the folder I'm currently in. Yeah. So it's like coding from the ground up. yeah, like we're learning the small bits, and then we're gonna learn the big bits to plug the small bits into. That's yeah, we're taking a bottom up approach to learning how to code in this class. But yeah, cool. So yes, just name your variables something useful, and we'll continue on next week because it's Friday. So have a great weekend, everybody. If you have any questions, I will stay online for a little bit longer, and we'll get that squared away. Oh, what is my GPU? It is the AMD Ryzen 5000 Series 7. That's what the sticker says. How do you hide the full path? Ha 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 ha! Well, it's a kind of interest. You'll just have to take 1xc3 because we've got a we've got a whole lab about how to make that kind of modification. Wait, so did I uninstall Windows? No, I didn't uninstall Windows. I overwrote Windows. Windows never had a chance to uninstall itself. I blew it out of the water. I dropped Linux on my hard drive like a bomb, and it just blew up Windows. That's how it worked. I mentioned it a day earlier to work on your own personal projects. What was my first personal project? Oh my goodness. Oh boy. My first project was I tried to make a video game in Flash in high school. That was my first one. It was not very good. But it was mine. Don't delete System32. Don't do it. When you use the math library, how far does it round the value of pi compared to doing it manually? I would imagine that it would round it to floating point precision. So as much precision as you get out of a floating point number, that's how much precision you'd give pi. What's the CPU? Oh, man. I think it's like a 8-core AMD something or other. Whatever one of the recent AMDs is. Oh, is that the CPU? Okay. What's the GPU? I don't know. Yeah. Yeah, what's the difference between mathematics and computer science program and the computer science program? I'm assuming the mathematics and computer science program takes more mathematics courses and fewer computer science courses. Yes, I forget what the GPU is, and I took the sticker off. So, ooh, yeah, if you're installing Linux with a dual boot system or installing Linux natively on your hard drive is kind of like gambling on the stock market. Don't invest anything that you're not prepared to lose. This weekend, is there any specific work that I would like you to complete? You could try some of the coding bat problems, but aside from that, yeah, it's we're not really that far into the course yet, but coding bat Python. Yeah, like if you did some of the warm-up problems here in coding bat, I'd say that's good practice. You could probably it's sometimes good to try things that are a bit beyond what we've tried in lecture so far. But yeah. What is my opinion on Windows 11? Yet another one? I have no particular opinion on Windows 11. I know Windows is trying so hard to be a decent operating system, but, nope. Pure Linux for me, I'm afraid. Yeah. You're in the market for a new computer and you think a fresh start... You think you should start fresh with Linux and avoid the catastrophes. I mean, you do have to adapt your workflow a little bit, but if you're worried about not having Microsoft Office, like so much you can get through just a web browser these days that, it's mattering less and less which operating system you have if you want the God's honest truth. Like, many of these, like, I don't have Teams installed on my computer. I use it exclusively through the web browser, so you know, if they can get it to you through the internet, then you don't need to worry about what operating system you have. But yeah. Can you run Linux off of a flash drive? Yes. Do you have a tutorial today at 11:30? Possibly. I can't remember. Yeah, so the way that you traditionally install Linux is that you burn a Linux ISO image, a disk image of Linux, to some kind of bootable media. So that can be a USB flash drive. So you burn Linux onto a flash drive. I would recommend backing up that flash drive, because again, that'll delete everything on the drive. So you take that, you plug it into your computer. It depends on the computer. Sometimes you have to load that from the BIOS menu. Sometimes it'll just boot up. If it detects bootable media, it'll just boot to it. But depending on your computer, it's hold F2 or F10 as you press the power button. That brings you into the BIOS menu, and then you can choose what operating system to boot, including the one that's on the USB drive. And from the USB drive, you can then install Linux, or partition your drive, or do whatever you like. But yeah. Yeah, the CAD programs might be an issue. That's the only thing. Well, if you're getting a new computer anyways, I would recommend dual booting. A dual boot system is where half of your hard drive is Linux and half of your hard drive is Windows, and when you fire up your computer, you have an option of choosing either Windows or Linux to boot into. But yeah. Yeah. So Ubuntu is a very good, very vulnerable, very well supported. Mint is the new one that's on the rise, though. Mint is now more popular than Ubuntu. Popularity of Linux distributions. Distro watch. Yeah. So. Oh, Manjaro. That's interesting. So this is this is based primarily, it seems, on download count or something like that. So yeah, in the last month, Mint has been number 4. Debian's up there. That's funny. Yeah, Ubuntu is a good one. MX is very popular these days. Generally speaking, you can count upon the Linux community to know what's up. So if a Linux distribution is popular, it's not because of normies. But yeah. Okay. I am curious to know what type of questions will appear on exams and tests. Will they only have programming questions? They will only have programming questions. We're not going to quiz you on multiple choice or anything like that. It's going to be application questions only. Mint Cinnamon a while back, and it was easy to work with for the first-time Linux user. Yeah, I'm running Mint Cinnamon right now. Pretty. Ooh. Is getting a MacBook a bad choice for a CS student? If you're in the full CS stream, I'll put it to you this way. Mac isn't a bad choice. A lot of the professors like Macs. A lot of the professors use Macs. Macs are perfectly acceptable. Windows, in fact, is perfectly acceptable. But the question is, you know, it's kind of like up to you. Do you want to have the full Linux experience? I would, like, there are areas where people will make fun of you for having Linux, because it's like, ooh, look at you and your hipster operating system. But those of us who are, in the CS, like, people who are in the department itself, it's like, no, you kind of need it for work. Like, there's a lot of programs that are Linux exclusive that, you would need if you would go to grad school and that kind of stuff. So, like, yeah, it's like, do you want to learn Linux now or when you're a, over-busy, over-caffeinated fourth-year student? Yeah, Debian is always a great choice. Yep. Have a good weekend. Yep. Yep. Yeah. Also, for the same price as a Mac, like, the other thing about Macs is that they're super overpriced for, like, what they are. But, that's just my opinion. Then again, I took a gaming laptop and installed Linux on it. So, it's not like I'm going to be running a bunch of, like, video games that are, it's not like I'm going to be running Crysis on this guy because I don't have Windows even installed, but, I just like the power. The raw power. But yeah. Cool. Anyway, that's it for me for today, I'm afraid. Take her easy, folks, and have a nice weekend. Bye-bye.